Stepwise regression dances through data, keeping the variables that truly move the rhythm of the real world. Welcome back to my channel. Hope you all are doing good. Today we are going to understand a real world scenario or real world project on stepwise regression, and we will understand complete step by step out of it. So let us start. Let us understand on how stepwise regression works with the personal insurance dataset, and I'll explain you the dataset, what are the features present and all. What is the first step, guys? We are importing our libraries. First point, right, where we are importing matplotlib, pandas, numpy and cbom. Then I'm loading my data. So again, I'm telling you that I'm going to add all these things to the GitHub. Please take it from there while practicing. Then this is my head of the data. This is my personal insurance data. And what are the features it contains? Before proceeding anything, the first point is to understand the core subject on what you are working, right? So that is the first thing we have to understand. We need to know, as it is a personal insurance or it's related to person's insurance. So for that, what is the driving factor? First, age, then the gender, then BMI, right? Then children, how many children that person is having. Then smoker, if a person is a smoker or not. Then region, then charges. This is the final insurance charge. After going through all these tests, it's going to be indicated or it's going to be applied. Then what is the next step? We need to know the info part, right? What my info part is going to give you. It's going to give me the total number of rows. So I have 1338 rows present. My data types are here int, object and float. So I have collectively 4 numerical and 3 categorical values or variables. So this is my statistical descriptive statistics for numerical variables, right? So we have age, BMI, children and charges. These are your descriptive statistics part. Then what is the next step, guys? Before moving ahead, do we have any null values present here or not from this data set? We do not have, right? Because if we have null values, then it should be, this count should be lesser, right, for each row, because those places where the points are less, that is containing your null value or NN, right? Then, and I can see that I don't have any duplicates. Oh well, I have one duplicate, so it has removed. And finally, I am able to see 1337, right? You can see we have total 1338. Now I have 1337 rows. So data dot shape. No, I think this is the index part. My bad, guys. This is the index part. And I don't have any duplicate values, just for your understanding, okay? So this is my shape and these are my columns. So these are my columns: age, gender, BMI, children, smoker, region and charges. Then these are my numerical and categorical variables, right? So we understood all these things. Now we saw, okay, we have categorical, so we need to convert them to numeric before proceeding to model training and all. So we got all those steps. Now what is the next step? We have to understand our EDA part, exploratory data analysis, right? Where first point is I need to understand the correlations between the variables with core method, correct? That is the first point. So what I did, I have taken age, BMI, children and charges, because those are my numerical variables, and I can see that none of the variables are having a strong correlation here. You can see only this age is having some values which are greater than greater than 2.2, and BMI is also having some effect. You can see age is having some good correlation with charges, and BMI is having some good correlation with charges. However, none of them, every value is having very limited or very less amounts, right? 0.068, 0.013, 0.042. Children is not at all giving any sense to the data set. However, that can be a driving factor, right? So we don't know. We will explore that. So we understood our heat map section. Now, and from the heat map section, what I understood is I do not have to drop any variables because that is fine. I mean, all are moderately related. However, we do not have so much of features that we have to drop anything here. Then what is the next step? I want to see my outliers. However, are we going to consider these values as outliers? We do not, right? Because these are very near values. And you will see, before proceeding, right, you have to see what are the highest and lowest points for age. So, my age is starting from almost 15, you can see. And it's closing at around 70 to 75. So, that is a valid age consideration. Then BMI. Usually people have 27, 24 like that. However, the BMI people are so, fatty or obese. In those cases, the BMI is crossing this 47, and these are your BMI, right? Highest BMI till 55 or 62 and till that. That means those are obese people. Children, it is fine. There is no outliers. We are not able to find charges. However, the median value it is telling that it should be somewhere around 35,000. Maximum charges are given to people with the range of 35,000. However, there are charges which has been provided in the exceptional cases where suppose the body mass index is more or age is more. In those cases, people should be provided with more insurances because those are more disease-prone people, right? Then what is the next step? We have to find out reg plot, right? Reg plot, because I want to know how my data is getting distributed, right? So I can see that it's moderately, this is not a proper reg line. That means it's not highly correlated because I am trying to draw my age and BMI. However, age and BMI should be related to each other. It's not a curve like this. It's just, a little bit aligned towards regression line. Then, this is the next one I want to know, and I can see there is some bend or sorry, there is some curvature between children and age. Then we have age and charges. That's obvious, right? Charges, the more you can see it's related, right? As the way we saw in heat map, collinearity map. Here, what I am seeing that the 60 age of 60, and you can see that with age of 60, we have it's a direct correlation. The more age, the more insurance. You can see the more age. You can see this concentration of data. The more insurance, right? So that's how the regressor is looking like in case of age and charges. Then I want to know my count plot for children because that's my quantitative data, right? Why I want to see that? I want to know that the particular person who is getting insured for some criterias, that person, those people are having how many children? Because children is also going to be a part for getting insurance because those should be getting insurance, like added insurance along with the parent or along with the person. That's why I wanted to check. And all I can see that the maximum amount of children or the maximum amount of insurance people are getting where they do not have any children. So that is one of the factor I wanted to consider here. And I can see that around 600 people do not have any children out of that lot. So we have around 1300. So almost 50% people do not have children, and those are getting insured. And this is the scatter plot between age and children. So you can see that. The people, how to read this? Let's see that. So the people, the people who are with 20 years, they have 0 children. We have people who are with 20 age and with 1 children, 2 children, 3 children, like that. However, we do not have any children with 4, like any people with 20 years age with 4 and 5 children. Those are coming with 40, 30 years and like that. So that's how we can read it. Now, what is the next step? We have to encode our data, right? So for that, what we have to do? We have to perform our ordinal encoding, correct? So for that, I should be. So I have defined, or I have imported my pre-processing. That's a ordinal encoder is a pre-processing library, right? So I have done that. So now I'm not getting any issues. So I'm going ahead with my head part, and I'm able to see my head is containing all numerical values present. Now what is the next step? I have to go ahead with my feature selection, or I have to go ahead with my creating my dependent and independent variable. Then after that, I have to train my model, right? So for that, charges is my target variable, because here I want to know, based on the factors or based on the criteria, what is the insurance amount people should be getting. So for that, I have dropped, like for my independent variable, I have dropped my column charges and I have assigned it. And for dependent, I have directly taken my charges. So this is what I have done. Then my next step is, I want to get my linear model. I want to get my train test split, and I want to get my metrics, and along with that, I want to get my feature selections. So before moving ahead with my feature selection, I have used ML extend, and I have already explained you in my slide that ML extend is one of the method to perform your stepwise regression. So there is a feature selection property, or the feature selection module in ML extend. In that, I have imported sequential feature selector. Just mark this, okay? ML extend. And in case you are the first time you are using ML extend and you are not able to get it, you are getting ML extend is not found, then you can use pip install ML extend. Let me write it here in a comment so that it will be easier. Pip install ML extend. And where you have to do? You have to do it in your Anaconda prompt. There, if you type pip install ML extend, it is going to install that particular packages to your Jupyter, and you will not get any kind of error further, right? So you can do that. Go ahead and do that. And after that, I have, let me just do this. I imported all my libraries of sklearn and ML extend. Now what is the next step? I want to know. Okay, so I am just telling that my model should be linear regression. So I have taken it because I am performing linear regression, right? So I have taken a model for linear regression. Now I am using backward and forward elimination. Based on that, I am going to select my features. So what I did for that, I have taken a variable. In that variable, I have used sequential feature selector. What exactly this expects? It expects a model. Which model you want to take? I have taken my regressor model because it is going to consider the features for that model. First point, model K features. What I told you, it is going to consider your K features, alkaline, archaic and Bayesian, right? K features. and this is the one best. However, you can take a numerical value here, but I have taken best criteria. This is the default criteria for K features I have taken. Whether forward or not. Forward, if it is false, that means it's a backward elimination method. Scoring, it's add to score. I am taking add to score. CB equal to 5, that means cross validation. What is cross validation? It is a method where I am going to use for getting the models or getting the features which are not going to make my model overfit. And there are so many methods of cross validation. I am going to take one of the separate video for that to completely or to the extended understanding of that. However, just for now, just understand these are the criteria which are passing for getting your stepwise regression. And two methods which I have explained you in theory, that two methods I have kept it here. One is a forward and backward, and another is forward. So wherever forward is true, that means that's a forward selection or backward elimination, right? So K features is the one which I have taken. Then after that, I have taken SFS.fit. What I'm fitting my dependent variable and my independent variable. Then after that, what I'm getting that I have age, BMI, children, smoker, and region. So, however, I have 6 features. What are my features? Let me get the X dot columns. I have age, gender, BMI, children, smoker, and region. However, after careful backward elimination, it has removed gender or sex from that lot, and it has given me this final selected features for this model, the model which I'm using, right? Then the next step. Next is your ML extend and forward selection method. Here again, this everything I have kept it same. However, you can take, I have taken forward equal to true, and with this also I am getting the same set of features, age, BMI, children, and smoker and region. However, my original data dot shape is 7 features. In case of our the features which we are considering for our final one is going to be 5 features. So this is the purity, or this is the method of how good this stepwise regression works, right? Because it's completely eliminating the features which are not needed. And I have taken all my features and I have taken them and I have created a column, and I am creating my data frame for that. Now I can see this is my final head, right? Sorry, this is not my final. This is my final head, and I need to see the final column, right? I need to run this. I need to run this. I need to run this. So this is my final column, right? Now, instead of taking the data here, right, I need to consider my final column, because now I am training my data for what? For linear regressor model, right? Because that is the one which I am checking, correct? So I am able to see that my predicted values, these are my predicted values, and let me see the R2 score for that. My R2 score is coming around 76.9%, right? Which is good. Then these are my metrics, right? Mean square error, then mean absolute error, then RMS. So what we understood that after careful observation or after careful selection of my features, I can take those features and I can perform my linear regression, right? So this is how my whole stepwise regression method works. However, there are few more methods, like I have already mentioned. There are few 4 methods where we are using stats model, and in that stats model we are using p-value and all to evaluate your backward selection and forward selection or backward elimination. Those steps we can see that there are so much of intense steps where we are performing, and however I'm going to give one more, I'm not going to take another separate video for that. I'm going to share that code in GitHub. I will create that code and I'll give that to you. You can just take it for your reference for future references when you are practicing. So yeah, we have completed our stepwise regression, and we will see the next one or the next algorithms in our upcoming videos. Thank you. We have completed our stepwise regression, and with a real world example, we will understand or we will cover further regression algorithms in our upcoming videos. And next, we will start with our classification algorithms and its relevant topics. So, start subscribing if you have not done that. If my contents are helping you in your daily life, daily applications, do that. Like, share your comments, share your valuable feedback, share this channel link to all your friends and near ones whoever are in need in learning this. We will see in our next video. Till the time, thank you. Bye.